Select the correct statements. The value of compressibility factor Z for hydrogen gas is greater than 1 at room temperature and pressure. Now, if we talk about hydrogen gas, let's draw its curve for Z versus P, right? The hydrogen gas is something of this sort, correct? And at room temperature, if we remember, hydrogen gas does not really, liquefy. It requires temperature lower than the room temperature to liquefy. Therefore, the compressibility factor is actually less than 1 since it's not compressing, okay, for hydrogen at room temperature and pressure. Therefore, statement A is correct. The real gas behaves as an ideal gas at Boyle's temperature. Now, when we talk about Boyle's temperature, it is that temperature at which the curve looks somewhat like this. In the low pressure range, the real gas does show inclination towards the ideal behavior. Okay, and so that temperature is the Boyle's temperature, and statement B is also correct. Now, statement C. For a real gas following the Vanderwaal's equation of state, the expression of critical temperature is 8A divided by 27 RB. This statement is also correct as we have studied that the critical temperature is 8A divided by 27 RB for any gas which is following the Vanderwaal's equation of state. So statement C is also correct. Talking about statement D, at low pressure, the compressibility factor Z is equal to 1 plus Pb divided by RT for a Vanderwaal's gas. So when we talk about the compressibility factor, we'll first have to write our Vanderwaal's equation. Okay, P plus A by V square into V minus B is equal to RT. At low pressure, this term is what gets neglected. So P plus A by V square into V is equal to RT. PV plus A divided by V is equal to RT. Dividing by RT on both the sides, we get PV divided by RT plus A divided by VRT is equal to 1. And PV by RT by definition is Z. So Z comes out to be 1 minus A divided by VRT. So statement D is not correct because we are not getting this particular expression. So the only correct options will be statements A, B and C.